Here's where we ended on Friday. This right here is the standard form of a circle, standard form. But what I introduced to you all on Friday was this form, x minus h squared plus y minus k squared equals r squared, which is referred to as center radius form. Okay, that's center radius form. So what I was in the middle of doing on Friday was trying to take my standard form and convert it to center radius. And the way we do that is a process you guys did learn last year in algebra, completing the square. That is how I convert it. I complete the square. So let's go over this again, because I was right in the middle of it when I decided to end class, because it's too important. It's too important. First step, make sure that single number is on the other side. Everyone see the -8? It's on the other side. Perfect. Second step, group the x's and the y's together. Rewrite the equation. X squared with -8x. Y squared with 2y, all equal to -8. Now let's start this complete the square process. You're going to do it twice. Once on the x's and once on the y's. First step to complete the square, you're going to add a number to the x's, and we're going to add a number to the y's, because we're doing this twice. How do I figure out what number to add to the x's and the y's? Everyone ready? Take the x's. X squared minus 8x. There's an a and a b value. What's the b value there? X squared minus 8x. What was my b value? -8. So everyone, don't yell anything out in your head right now. You take that b value, -8, cut it in half, and then square it. So -8 divided by 2, and then I square it. Everyone got that number? What is it? 16. -4 squared, 16. Do it again, but now for the y's. What's my b value up here now? I got y squared plus 2y. What's your b value? 2. Everyone in your head, cut it in half and square it. Take 2, cut it in half and square it. Got that number? What is it? 1. So that's what I add on to the y's. And I don't know how far I reached on Friday, but this is unbalanced now, right? Because you added 16 and 1. Now it's tipped too heavy to the left. So to balance it, make sure you add whatever you added to the left to the right side. To the right side. Most commonly misstep in completing the square. Everyone all right? All right, here's where I'll slow it down because I think this is where I got cut off. Factor. X squared minus 8x plus 16. You got two numbers that multiply to 16 and add to -8? I hope so, and they should be the same. Two numbers that multiply to 16 but add to -8. Tammy? -4, -4. So you guys would probably factor it like this, right? X minus 4, X minus 4. Clean that up. How do you rewrite that a little more creatively? X minus 4 all. Okay, we're starting to build now, aren't we? X minus 4 all squared. Plus, now do it for the y's for me. Two numbers that multiply to 1 but add to 2. Multiply to 1 but add to 2. Multiply to 1 but add to 2. 1 and 1. Write it creatively. What's it going to become? Y plus 1 all squared. Oh, now I'm starting to see a little circle equation, aren't I, in center radius form. Equal to, combine your like terms, 9. And look what I have there, center radius form. Center radius form now. All right, now I can call on you guys. Give me the center from Friday. And what's the radius length now from Friday? What's the center of this circle now that it's in center radius form? Center of the circle? 4. Griff, what's the center? Good job. 4, -1. I just changed the signs. And what's my radius if I got a 9 hanging there? 3, Eva? Convenient, huh? 3. Yep. And then, yes, we can graph it. Can we just not waste time and just freehand it, please? We'll be using your compass enough later on. So 4, -1. And then you go 3 up, 3 to the right, 3 to the left, 3 down. There you go. That's why I guess I don't freehand it often. Yes, yeah.
So why would you use 4, -1 instead of -4, 1?
Okay, remember the formula. X minus h squared. What must have been plugged in for h for me to get x minus 4? Just a 4, right? And what must have been plugged in for k for me to get a positive 1? Y minus a -1.
Okay.
So that becomes +1. Good, you're welcome. Anybody else going? All right, 1 doesn't make us great, and I want to start calling on a couple people to see if we're picking this up or not. All right, next one, standard form. First step, get the single number over, which it is not, and to group the x and the y's, which it's not either. So everyone, rewrite this equation. X squared plus 8x plus y squared minus 14y. Kick that 40 over, -40. Remember, you are completing the square twice, once on the group of x's, once on the group of y's. Plus something plus something equals -40. Half your b values squared. Half your b values squared. Bless you. All right, what are you adding on to the x's here? What are you adding on to your x's? 16, what are we adding on to the x's? 16. Look at that, convenient today. It knows. It knows something. Good job. What am I adding on to my y's now? Half your b value squared. 5, 49. -7 squared is 49. Do not forget, your equation's unbalanced. It's unbalanced. Don't leave the -40 hanging there. Add your 16 and 49. Factor it. 2 numbers. First, let's do the x's. 2 numbers that multiply to 16 but add to 8. 2 numbers that multiply to 16 but add to 8. What are we thinking about factoring that first one now? 21. 4 and 4, right? So x plus 4 all squared. It would be x plus 4 plus. How about factoring y squared minus 14 plus 49? 2 numbers that multiply to 49 but add to -14. What do we got for that one? 6.
49. Oh, sorry, I already have that. Y minus 7.
Y minus 7. All squared. And then over here I should have, what, 25? I'll tell you this. Why not? Somebody's going to figure it out sooner or later if you haven't already. There's no need to factor. I can tell what this number is going to be just from this. Anybody? How can I tell looking at this what that number is going to be? Same thing here. I knew it was going to be -7. Avery?
Just about that.
It's just half your B value every time. Okay, it's always half your B value in there. All right, take it for what it is or keep factoring. It's up to you. All right, let's finish this. Center and radius. Nine, center. -4, +7. And how about radius length? 4. Griff? 5. On fire. -4, 7. I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I'm not going to be able to get 5 above, so I'll just do my best. Ooh, looks good. So there's completing the square. There is completing the square. Any questions? So what I'd like you to do right now, in your packet, please go to page 55. Go to page 55 for me. And in addition to doing the packet page 56 tonight, you're also going to include the ones we crossed off, which is completing the square. So add on page 55 for the homework, page 762, page 762, 24 to 26. Okay, I'm just adding on what I had you cross off over the weekend. Okay, so page 762, 24 to 26. And again, you don't have to graph these. All right, just find the center and radius. No need to graph. All right. Questions on the homework you did have to do? Minus 24, 25, and 26, which is, as you can see up on my board here. I'll be all completing the square tonight. Anything you want to ask from last night? Somebody asked about 35 in the previous class, but you don't have to. You guys all got that? How to find the center and radius from that problem. So we're all good? Okay. If we're all good, I'm going to come around and check. You guys prep yourself. Compass, straight edge, if you need any, they're up on the front. Prep yourself for me. Again, don't forget about 24, 25, 26 tonight.
Lauren, you got your notebook?
All right, I'm going to jump right into this. Just go through 4 constructions today. 4 different constructions in a circle. To be honest with you, this first one is not new. It's going to be a review we've done probably, I think I showed you at the beginning of the year. Probably did it halfway during the year. Tangent line. What do you know about a tangent? If I look at a diagram, how am I going to know a line is a tangent line? Tell me something about a tangent line. 17?
It only goes through the circle once.
Only goes through the circle once. Correct. Correct. You'll see I point P here and I put the center. What I'd like you to do right now, grab your straight edge and make an extended radius through P. Okay, an extended radius through P. Based on a theorem we've done this unit, when I end up drawing this tangent in, what are you going to know about your radius and your tangent when I actually draw this in? They should be what? After I'm done with all the construction, I draw my tangent line in, the radius in your tangent should be 24 perpendicular. So that's what I'm going to ask you guys to do. is can you make a line that's perpendicular to this extended radius that goes through P? Because if you can make a perpendicular line, I guarantee that line's going to be tangent. So the question is, anybody remember how to do that? I want to make a line going through P that's perpendicular to your radius. It's got to go through P. Got to go through P. So if anybody's thinking, hey, let's do the fish construction here, not going to fly because I don't know if it's going to go through P or not. It'll be perpendicular. I just don't know if it'll go through P. Probably not. So there was another way I could get a perpendicular line through a point. Serena, talk to me.
So you can find measurement from P to the center of the circle with your compass, and then do that as point P, and then you can do the fish thing.
Okay, I wasn't thinking that. That's one way. Yeah. Find that distance, mark it here, and then that's going to be your line segment you do the fish on. Yep, you can do that. Nope, that's one way. Anybody else? See if it works. Go ahead and try it for me.
I did.
You did it work?
Yeah.
Okay, good. Wasn't my way, but it's fine. Anybody else? Put your compass point on P. Do it Serena's way too. It's going to get the job done. Put your compass point on P. Everyone remember making kind of like either a frown or a smile here. I need you to make an arc that intersects your radius twice. All right, that's what I need. I don't care if it looks like happy, sad, whatever. Make an arc that intersects your radius twice. Boom. Usually when I do this construction, I like to open up the second and third step. I like to open up my compass just a little bit more. I'm always afraid that when I have my two arcs that intersect, they'll intersect right on P. And I'm going to be like, where do I line my straight edge up with? All right, you guys have 2 points of intersection on your extended radius. Everyone's got 2 points now on your radius. Go to one of the points. Go ahead, go to one of those points of intersection on your radius. And you can do this above or below your first arc. It doesn't matter. Do this above or below your first arc. Make an arc above or below. Go to the other point of intersection with the same compass opening. And make sure those last two intersect each other. And then line it up. Point P and that point of intersection. Because you know are guaranteed that these two are perpendicular, that's got to be a tangent. That's the only time it happens, right? We just did a construction that said, hey, this line is perpendicular to that radius, so that has to be a tangent line then. Any questions you guys have? Oh, I love these next three. Gets me all fired up, these next three. Ooh. Inscribe a square. Where do the vertices have to be? On the circle. Good, Matt. Can't just do one of these bad boys and I'm a square. Got to be on the circle. The sides of the square are going to be what in the circle? What would I know they're sides in a square, but what are they going to be called as far as the circle goes? Griff?
Chords.
Everyone agree those are going to be chords? What do you guys know about the sides of a circle? Yes. Sides of a square. What do you know about sides of a square? They're all equal. So I need to make 4 congruent chords. 4 congruent chords. Okay. The chords will be congruent only if what are congruent? We had a theorem way back. I think it was day 3. If I have congruent blank, that means the chords are equal. Arcs. Yeah, thanks, Eminem. Arcs. All right, arcs. So what am I asking you to do to this circle? Break it up into 4 congruent arcs. Yikes. Because if the arcs are equal, so will the chords be when we draw. How am I going to get 4 arcs out of this? Somebody in second period was just like, oh, just do it. There you go. 4 congruent arcs. Just do it. I don't think that works that way. Why the heck do I have a compass in my hand? Can you guys give me 2 congruent arcs? Without even using your compass. Can you get me 2 congruent arcs right now? How, Jonah?
You just have to divide the circle into 2 semicircles.
So draw what?
A diameter.
Go, take your straight edge, draw a diameter in. You'll have 2 congruent arcs. We'll worry about how to get 2 more. Take your straight edge. Divide it up into 2 congruent arcs at least. There's 2. How do I make that into 4? Good, Serena, suggestion?
You could draw a line perpendicular that passes through T.
I don't want to draw one. I want to construct one. Right? So what I'm going to do is cut this in half. Cut this in half, right? I want something that looks like this. So I'll have 4 equal arcs. How do I cut your diameter in half? You tell. What? There we go. How do I cut that in half? Take our compass and put your endpoint on one point. You tell me what to do with my compass now. Griff?
More than halfway.
Yep, more than half. And we should know, be guaranteed more than halfway is put that bad boy past T, right? Because T is the halfway point. And make a decent size arc. Almost like a half circle. This is the fish, yes, if you're wondering. Boom. Go on the other side. Same size arc, so you have 2 points. Some of you guys like to stop here and be like, I'm good. No, you need 2 points of intersection. Then draw in the other diameter. Now you have 4 congruent arcs. So if you have 4 congruent arcs, you're about to have 4 congruent chords. Draw them in. Draw in your 4 congruent chords. You got yourself a square. So you need 4 congruent arcs. I'm not done with you yet on the square. I totally understand why the sides are equal. Congruent arcs imply congruent chords. Totally understand that. Anybody want to prove to me, what do you know about all 4 angles in a square? All 4 angles? They're right angles. Anybody want to prove to me how I know that that is definitely a right angle? Other than it's a square. I need more than that. Need more than that. Jonah?
It's an inscribed angle in the chord, or the. What is it?
Yep,
The
it's an
arc inscribed.
inscribed angle. Where's it drawn to?
Diameter.
A diameter. There you go. Take half of 180. You got yourself a 90. Unbelievable. Any issues on the square or the tangent line? I am upping the game now. Up your game now. Hexagon. Whoa. Based on our work from the square, how many arcs, congruent arcs, am I going to need here? 6. Yeah, 6. Don't be second period and tell me to cut the 4 in half. That gives me 8, not 6. Sorry. Okay, so I can't do that. All right, I can't do that. How do I get 6 congruent arcs? All right, you ready? There's no review here. I got to show you. On your circle T, put any point on circle T. Don't draw anything in. Just put a point somewhere on circle T. Take your compass. No arc marks, but just take your compass and measure the distance from that point to T. That's all I want you to do. No arc marks, just measure that point from your point to T. And here's what we're going to do. We're going to go around the circle, making arcs that same length. So watch. If you haven't done so already, put your compass point on the point you made. Make an arc mark that goes through your circle. Now this arc is the same distance as the radius, right? All right, travel up to where you just made that arc mark. Travel up. Make another arc mark that same distance away. Make another arc mark until I have 6 arcs here. Keep traveling around. What do I have? 1, 2, 3, 4 arcs now. And here's 5 and 6 coming up. When you're ready, if you don't believe the method behind my madness, take your compass at the end and literally measure each side with your compass and see if they're all the same length. And you'll see all of them. You don't have to open or close your compass at all. They're all the same length. Everyone all good? Hexagon, regular hexagon. Square, hexagon. Last one for you. Equilateral triangle. Not saying anything. Not saying anything. Think about it before we put compass to paper. Let's start here. How many equal arcs are you going to need? 3, right? Okay, I'm just going to leave it at that. Any thoughts? I'm just going to start and stop there. Though, yes, we do need 3 congruent arcs. You are correct. Buddy, have any thoughts for your classmates? How we can get 3 congruent arcs? Sure, Jonah.
We just have to make 6 congruent arcs like we did before, and then only use 3 of them.
There we go. Your answer? Your answer? We already did this. We just did it with the hexagon. It's the same exact. construction. Same exact one, except now you connect every other one. Make sense? All right, so same exact one as the hexagon, except now I'm going to connect every other chord. So really, you don't have 4 constructions you learned today, it's only 3. There you go. Equilateral, hexagon, same one. Any questions? All right, you got plenty of time. You got 2 constructions for homework, and then you can grab a textbook or your online textbook and get those, complete the square ones done. All right, no reason to pack up early here. Tomorrow's review day. Quiz 3 review. Quiz 3 on Wednesday. And I'll be here tomorrow after school if you want to stop by. Whew.